In addition to being able to find a missing side of a triangle, we can also find a missing angle measure. It's not much different. We're going to set it up the same. We still need to start by labeling which side is the hypotenuse, which side is the opposite, which side is the adjacent. But then when we go to solve for that angle, we're going to have to do something a little bit different. So let's go ahead and dive right into 5A, labeling the sides. This is our hypotenuse with respect to theta, which is just a Greek variable. We call it theta. Going across the triangle, we find the opposite side. There's nothing on this side, so I'm not even going to bother labeling it the adjacent because I would just cross it out anyway. And the trig function that's going to connect the opposite to the hypotenuse is the sine. So the sine of the angle is the opposite over the hypotenuse. Now, if you want, you can put that in lowest terms. You don't have to. It's just simple to do. It's 7/8. Sine of theta is on the left. We want it to just be theta. In order to get rid of the word sin, the trig function, we can't just divide by sin. It doesn't work that way. You would not get the right answer if you try that. What we need to do is take the sine inverse on both sides. We'll do it over here too. So on the left side, they cross out and we're left with just theta. On the right side, we need to type this into our calculator. Sine to the -1, 7/8. Flip back to our calculator for a moment. Sine inverse of 7/8, again, making sure that you're in the proper degree mode, gives us 61 degrees. So theta is approximately 61 degrees. Go ahead and pause the video and try 5B on your own. After labeling the hypotenuse and the adjacent, hopefully you realized you needed the cosine function. And after solving, you should get 65.4 degrees. So why do we want to find these angles in these sides of triangles? Well, it's because triangles are very, very useful in indirect measurement. That's where we find ourselves using a lot of trigonometry. Things that would be too difficult to measure directly with a ruler or a tape measure, we can use these angles and measurements that we do know to figure out the measurements we don't know. So a couple of terms here. The angle of elevation. If you look right here, this person, there's the eyesight looking straight out. If that person were to tilt his head up, it would elevate. So now he's looking up at the sky. That's called an angle of elevation. Similarly, the pilot up here in the plane is looking straight out. But if he were to look down towards the ground, that would create an angle of depression. So let's see where we can start using some of these angles in real-world problems. A ground crew worker who is 6 feet tall is directing a plane on the runway. And I believe he kind of got cut off. Here's the person right over here directing traffic. Okay. If the worker sights the plane at an angle of 32 degrees, so you can see he's looking up 32 degrees from where he normally would look straight ahead, what is the horizontal distance from the worker to the plane? So the horizontal distance is right here on the ground. That's what we're trying to figure out. You can see it's just like example 5. We have all the information and we've been given the picture. That's usually the hardest part, is to construct the picture. But here we have the picture. We know that this is the hypotenuse over here, but we don't want to know anything about this side length. We know this is opposite, and we know this is adjacent. So we know that the tangent of 32 degrees is the opposite over the adjacent. And now we're going to solve for x. So we're going to multiply by x on both sides. Doesn't get x by itself, but it certainly rescues x from the denominator. And now we're going to divide by tangent of 30. Remember on example 5, I said we couldn't divide by just the word sin. As long as there's a number with it, you are allowed. You may proceed. Because the tangent of 32 is a number. Just the word tangent is nothing. All right, so let's type this on our calculator. 150 divided by tangent 32 is roughly 240 feet. And since this is a real-world example, make sure to put some units on that. All right, looking at guided practice example 6, it's very similar to the one we just did with the airplane. However, one thing that we have here in this triangle, we have this side, we have this side, we have a 90-degree angle, but we don't know the other angles. But one thing you need to know is that this line and this line are parallel, which means what we actually have here, we actually have alternate interior angles. Just going to mark it here, right here. Those are alternate interior angles, which means they are congruent. So this angle down here is simply 36 degrees. So now you have the information in your triangle to solve for this unknown side. Pause the video and try it. You can see that x is approximately 2,064.6 feet. Sometimes we will have a problem that's even a little bit more complicated using multiple angles of elevation or depression, as you can see here. We have a hot air balloon that is moving above a neighborhood. It has an angle of depression right here of 28 degrees. That's looking to this house. But if the people want to look down to this house, the first blue house, that's an angle of depression of 52 degrees. If the height of the balloon is 650 feet, we want to estimate the distance between the two houses here. So if we look at this side length right here, that's what we're trying to find. That side length is part of this triangle right here. But that golden triangle that I've drawn isn't very helpful because it's not a right triangle. And so far in step 11, we can only do these problems if we have a right triangle. So instead of using this triangle, we're trying to figure this out. Think about it this way. We could figure out this triangle first. Imagine ignoring everything else that you see here in the picture and looking just at the golden triangle. You have enough information now that you could solve for x. You might say, well, that's not what they're asking us for. You're right, but we're going to solve for what we can and then go from there. So this is the opposite and the adjacent side. The tangent of 52 degrees is 650 over x. And then if we solve, we know that x is going to be 650 degrees divided by the tangent of 52, 650 feet divided by the tangent of 52. So let's plug that into the calculator. $507.8. So the distance from where the balloon is up in the sky all the way over here to the blue house is 507.8. All right, well, we know that this triangle over here with y in it is what we need, but we can't use it because it's not a right triangle. So let's look and find another right triangle in the picture. We have this right triangle. For this right triangle, we have an angle, 28 degrees. We have an opposite side, and we have an adjacent side. It's 507.8 feet plus y feet. So let's set this up for our second triangle. We could say that the tangent of 28 degrees, because now my angle is 28, before it was 52, is the opposite over the adjacent, 507.8 plus y. So it's a little bit more complicated than what we started with originally, but it's not that bad, because what we're going to do is solve it the same way we solved the other one. We're going to multiply both sides by 507.8 plus y. And now that cancels. And then we can divide by the tangent of 28. (650) divided by the tangent of 28 is 1222.5. So this entire distance from here to here is 1222.5 if we subtract the 507.8 from feet. And that is what they asked us to find. This next one is much more complicated, so I'm going to create a separate video that you could watch if you want to, because the bonus question on the Step 11 quiz will be very similar. It's very involved, but that's why it's bonus. It's nice to know. It's a good way to be able to solve and use a lot of algebra skills, but it's not something I'm going to require from you. So I'm going to put a star here. This will be bonus if you care to take the time to watch the video and learn about how to set that up and solve. The last thing I want to talk about briefly is solving a right triangle. Solving a right triangle just means finding the measure of all the angles and the measure of the sides. So right here, we want to find side X, side Y, side Z. We also want to find angle X, angle Y, angle Z. If we have all 6 of these pieces, we will have solved the triangle. Let's write what we know. We know angle X is 35. We know angle Z is 90. To find angle Y, just take 180 minus 90 minus 35, and we will have what's left. So we already have all the angles. Now we just need to find the sides. We know that side X is unknown, side Z is unknown, but side Y is 10. And then we're going to use trig to find the other 2 sides.